Yeah, welcome and to this introduction to the BacDive database. With the next 40 to 45 minutes, I will tell you a little bit about this database and hopefully show you that the advantage of systematic access to prokaryotic metadata, which is not common. So to the outline, shortly, I will give some slides about the background of BacDive, where the data come from and so on, so that you get the background here. But then I would like to do a live demonstration to show you the basic functions and give you an overview about the data here. And in a second live demonstration, I want to switch and want to show you how to find strains by attributes. Coming to the end, we want to do a very short rally to engage you as a user shortly, so that you try to find a strain at BacDive. And at the very end, I will shortly talk about what BacDive is currently used for in research. So in the very beginning, what's the mission of BacDive, or what was the mission of BacDive? What you see here is a catalog entry of the DSMC, the culture collection. And you see already some data here. But the problem is for culture collections, or some other culture collections that show much less data. The point here is that culture collections producing a huge amount of data, of high quality data systematically. And this makes the culture collections to hotspots for prokaryotic data, of course, or data on microorganisms. The problem is most of the data is only internally available and not for the public research. And really can compare this with this tip of the iceberg picture here. So what BacDive started to do in 2012, this was far before FAIR and so on, we started to develop a database to make this huge amount of data available. And today BacDive has about 600 data fields on the topics of taxonomy, morphology, physiology, cultivation, origin, and sequence data. So that was the first mission of BacDive. And over the time, it's now 8 years old, this database evolved. So that is why I will shortly talk about the different sources that we have. So still the most important source for us are these internal descriptions of culture collections. And this is not limited to the DSMC data. We have other culture collections data here, like the Institut Pasteur or the Swedish collection and others. So this is still the high quality backbone of BacDive, but it's not limited to this data anymore. So what we also integrated over the time are expert compiled companion. So there are a lot of experts out there. They are collecting research data on microorganisms over decades. And then at one time point, they actually realize, okay, what will I do with this data? Mostly shortly before they are going to be retired. And so this happened to us 2 times that the people came to us and asked us, would you like to take this into BacDive? And of course, we want to. Unfortunately, this data is not always in a shape that you could do, that is easy. So what you see here, like it could be note cards or stuff like that. So it is, although it's quite a lot of work to mobilize, digitize this data, to standardize this data, this is, of course, worth it because this is excellent data. So that's the second part that we do. The third source here is taxonomy. Just 1 year ago, this was not LPSN, but PNU, Prokaryotic Nomenclature Up to Date. This was a service run by the DSMC to have up-to-date nomenclature. And just within the last year, our PNU has merged with a very famous web page LPSN, which was run by Aidan Part. And now this is a new resource called LPSN DSMC-DE. And you can regard this as a sister database to BacDive. So LPSN is caring about the taxonomy and the changes in nomenclature, and BacDive is caring about the rest. So this alone would be a nice topic to talk about, but this is not the focus for today. If you want to learn more about it, come back to me later. Okay, but we have last source here that I have to mention, and this is probably the most important for now. For a couple of years now, we started to mobilize data from primary scientific literature. Because of course, primary scientific literature is the largest source available for research data. We focus here on species descriptions, and so far we have already 6,500 species descriptions within BacDive available. Okay, what does BacDive provide for you? Of course, data. So far, we have data for more than 80,000 strains assigned to 14,000 species. And this is already very important. We collect data on strain level, not on species level, because it's much more accurate. And if you see that there are about 16 to 17,000 validly described species at the moment, validly described is important. We already cover about 85 to 90% of the so far described species. So that's also quite important that we already cover a lot, and we really want to close that gap with the next years. So what kind of data do we provide? We have different sections here, taxonomy, morphology, and so on. And what you see here is on the entries, we are a little biased. We have a lot of morphology and physiology data here. It's basically physiology data. Interoperability is most important for us, of course. And we do cover this by having all the identifiers available that make sense. Of course, we have culture collection identifiers to identify strains. We do have INSTC sequence session numbers. We also do have NCBI tax IDs for NCBI taxonomy. We have EC numbers for the enzymes. We have GB IDs for metabolites. And last but not least, we have digital object identifier, short DOI, to referencing our own strain pages. So for the access, of course, we have a web page available. This is free access. This is all the CC BY non-commercial license. We have data as a download, as a CSV download. There are different tools that can be used to search data, and I will show you two of those later on. And we have a programmatic access. It means RESTful web service here, which is also free, but needs a registration. This part is not part of this webinar today. If you're interested in this, yeah, come back to us. Okay, just before we start with the live demonstration, some important vocabulary. So type strain of a species. I'm sure a lot of you know that, but to make sure you all know that, type strain of a species is the first strain that is used to describe a species. And further on, this strain is the reference point to judge if there's a new strain. Is this new strain part of the species or not? So it's quite important. And for a lot of species, the type strain is also the best described one. So that's why we really care about those type strains in BacDive. Species descriptions, I already mentioned them. For those who don't know that, for prokaryotes, there is a special point that not all, but more than 80% of the species description happen to be in this journal, IGSEM. So this makes the journal, of course, as a hotspot for species data or strain data here. The species descriptions are in a very conserved format, which makes them easy accessible compared to other literature out there. Metadata and data. What is the difference? So metadata is data point. So this is called BacDive metadatabase. This is why was meant to be, because to complement with the sequence data. You have the sequence data, and then you always talk about the metadata. But it is data, and you will see in BacDive this is not only metadata. INSTC sequence session numbers, I already mentioned those. For those few people who don't know that about INSTC sequence session numbers, this is a consortium of the 3 large nucleotide archives that are synchronizing every day. And so with this sequence session numbers, these are valid for all those sources. And this makes the INSTC sequence session number probably to the most important persistent identifier that we have in biology. I'm not sure about it, but I would say that so. Culture collection numbers are also persistent identifier and still the best way to identify a strain. These culture collection numbers are given by the culture collections when they take up a strain. And so these are stable and usually used within the literature. The problem with those is over the time, a strain occurs in different culture collections. And therefore, the strain can collect a lot of culture collection numbers. So you always have to match, is this ATCC number the same as a DSM number, the same as a CCOG number, and so on. In those times where strain Infonet is not available anymore, it's a little bit more complicated. However, BacDive provides this data as far as we have it, but it's not the focus of BacDive, but it's used like this. Okay, so what's next? I want to talk about two major use cases. The first one is very simple one, is you already know a strain and you want to find more about it. And you check BacDive either directly via Google or with a simple search. But the second one is a more interesting one. We come later on, we talk about later, is to find a strain by the attributes. And therefore you have different searches that we'll show you later on. Okay, but we start with the very first use case, and I would now shortly switch to the live demonstration and then go on. So just a second. Okay, this is a BacDive landing page. I hope you all see that. And some of you might have been here already. There's a simple search, some additional data here, and the number of the total strains and the type strains over here. Before I continue, something interesting probably, BacDive has a responsive design. So if you're using mobile devices like tablets or smartphones, you should be able to use BacDive as well. It would look like this probably, right? You should just try out, use it with your mobile phone, and give us feedback about this. But coming to the first use case, you want to find a strain that you already know. Then you have here the simple search, and you have different options. So it says species name, culture collection number, sequence succession number, and so on. And if you start typing, we have an autocomplete function like this. It suggests you entries. And if you hit the enter button, you come to this result list. Within this result list, you have all the strains that are matching with some basic identifier that should help you to select the correct strain that you're looking for, including this information, is this a type strain or not? But you have other options as well. Give me a second. You can check for culture collection number, like this. You can check for INSC sequence succession number, like this. And just added a few months ago, you can also check for NCBI taxonomy ID like this. And if you hit now the enter button and there's only one entry that's matching, you get directly to the strain detail page. That's what I am doing now. So that is what we call a strain detail page. All the strain information is available here. And we go through this shortly, and I start at the very top over here. So that is what we call info box, to have the major identifier available, like species name, a strain designation, and culture collection numbers here to make sure, okay, this is the strain I'm looking for. You already see what I mentioned. There are different culture collection numbers, and they are all pointing to the same strain. And from this, these are links. You can then come directly to the culture collections. Then we have a summary up here, a short summary that gives you a short impression what this strain is about. Human readable, so that you quickly can check, okay, this is what I'm interested in. And then you have all the data in the different sections here. And what I did, I minimized all those, and you can minimize and expand them all at once, and every single one. So I go through this step by step. So we have taxonomy here. And as I mentioned, the taxonomy is all coming from LPSN database today. We are updating this frequently, and all the data here is linked to the LPSN database, as you see here. And we also have synonyms available, like here. Then we have the section morphology and physiology. This is the largest section, sorry. We have gram staining here, cell shape. Sometimes we have cell size data here, not in this case. We have data about the motility, about the colony, and so on. We have enzymatic data in a table. We have all the enzymes, and if these are active or not. And if there are EC numbers available, these are all linked to the Brenda database. We have fatty acid profiles available with the metadata and the fatty acids here, sortable. We have salt data on what salt concentrations this strain grows. We have RP test data. This RP test data, if you don't know what RP tests are, there's a question mark and you can find out more. These are short physiological tests. And we have a really large collection of this RP data. So actually we have the largest section worldwide. So if you're interested in this, really should you try out the RP test finder over here. Anyway, we have antibiotic data, antibiotic resistance data, this yes or no, and sometimes with concentrations, not in this case. We have metabolite utilization data. This is typically a table here, and you have the metabolites on the left side. Then you see if these are utilized or not. And then in the third column, we try to characterize the kind of utilization, because this is what you find in literature is very different. Sometimes they say, okay, it's assimilated, utilized. Sometimes they say it is carbon source and so on. So we try to be as precise as possible, but of course we are dependent on our sources. So it says here, okay, D-fructose is used as a carbon source here. And esculene is not hydrolyzed here. Nitrate is not reduced here, and so on. We have pictures sometimes. We have data about oxygen tolerance, if this is aerobe, anaerobe, and so on, if this is a strain is able to building spores. Within the next section, we have culture and growth conditions. We have, of course, cultivation media, which are most important, of course. And if these are DSMC media, these are linked here. We have temperature data. Also here, we try to characterize how this is tested. So is this gross or is this the optimal temperature? You see here. The same holds true for the pH. It's also is it optimum or gross data. Isolation and sampling, here we track where this was isolated from, the geographic location, the country, and so on. And here's something special. We have these isolation source categories. And these isolation source categories are made up by us. So we assign those keywords. Yeah, these are keywords actually to make these entries systematically searchable. And I come back to this in the second part of the live demonstration. Molecular biology is basically sequence data. We have the GC content. We have sequence accession numbers here. And yeah, that's probably important here to explain. We do not provide sequence data because there's a big nucleotide archives out there. This would not make sense. So we provide all the other data. So therefore, this table is most important to us to connect all our data to the sequence data. And yeah, you have the sequence accession numbers to ENA. If this is 16S, this is also a link to Silver here. And we have the NCBI text ID here. At the very bottom here, what you see here are the references. So you see here on the left, these links. Every single data point in BacDive has a clear reference. And so for transparency reason, we want to show where we got the data from. And if this is public, of course, you can go on and check yourself. Like this paper here, you easily can go there, read the paper, and compare to what we found, if this is correct or not. So this is quite quick tour to the strain detail page. On the right side, we have a menu where you just can jump between the single sections. This is handy if there's a really long entry. And then here on the right side, we have this exclude text mining derived information. Please forget about this for now, because we have a text mining amount of 0.001. This won't change anything here. So ignore this for now. We have this cite the strain. There's a DOI to cite this single strain. And we have the PDF archive. I will show you this shortly. So within the PDF archive, we track the changes over time because, of course, we adapt the strain information over time. There comes new. Sometimes there are mistakes that we correct. And so we track this within this archive. So if you reference to a strain in BacDive, this will always be to this version that you use for your research. This is what you see here. So, and then you're able to put this strain into your download selection. This is like a shopping cart. You can collect strains here, and then you can export the data in a CSV format. This is something that I want to show for now. So that was a quick tour to the strain detail view. And something that I want to show you next is a very new feature. This is our dashboard here in the statistics. So just a few months ago, we made up this dashboard. And this is very important to say this has no claim of completeness to completeness. So this is only to get an impression of the data in BacDive, get an overview. And but it's quite nice. It's a quite nice entry point for every new BacDive user. On the right side, you see you can limit this to the type strain information. But I will go with all strains for now. We have some basic statistics over here. And then there's a lot of data here. We have these different sections here, and you can go there through this and have a look, for example, on all the classes that we have. You see that we are dominated by actinobacteria and gamma proteobacteria. Can check morphology for this distribution of the cell lengths of the data that we have, or the cell width. You can also check for the cell shapes that we have, and you see bacteria are quite boring. They're only rod-shaped, most of them. Some are coccus-shaped, and that's basically it for the majority. So you can go further down. We have data about the cultivation, the oxygen relation, if the most are aerobe or anaerobe classified, salt concentration, the optimum of salt growth here, and temperature data like this. And what you already saw here is this is highlighting here. And this is a really nice feature here. So every single data point in every single graph here starts actually an advanced search. I would click on this one and see what I mean. And this is a really good entry point to go on and make a query on your own. I will come back to that in a second part. Okay, so every single data point is triggering an advanced search here. For metabolism, we splitted the metabolites in positive and negative utilized metabolites. The same holds true for enzymes. We split it in positive and negative enzymes here. I will skip the isolation sources for now. Here's my molecular biology. We have the GC content distribution very nicely and some other test data. So that was a very quick first tour, and I will shortly come back to my presentation. And so with that said, you have now an impression of what kind of data is in BacDive, how a strain detail view looks like, and how to find the strain. And now I would like to come to the second part, to the how to find strains by attributes. So you can have a quite complex example like this with a lot of attributes, and you can find a strain in BacDive. So that's what I will show you in the next 10 minutes or so. Give me a second. Okay, this is advanced search. This was the very first search that we developed in BacDive. And this is pretty simple. On the left side, you have all the query fields. On the right side, you have all the strains available in BacDive. And by querying on the left side, the right side is filtered, and thereby you narrow down the list of strains that you have. And you do this step by step. What you see here, it is a similar, not identical, but similar to the strain detail page, because it is overwhelming. It's like more than 130 fields here, and I won't go through all of them. But to make it a little bit easier, we structured it similar to the strain detail view. So if you're familiar with the strain detail view, we will be okay with that as well. We have different types of data fields here. We have this text fields like here. Where you just write in here and search them and filter them. And you have different operators here. You can say it contains, exact, begins, ends with. So that's good for now. We have this drop-down list. Here I can select if this is a type strain or not. I say yes. And what you see here on the right side, you see the data that I query, the data fields occur here. Okay. And a very handy function here is this asterisk here. It already says here in that asterisk to show all entries. So what this asterisk does is it activates the data field without filtering. So for the beginning, it's quite handy to do this just to get an impression what's in this data field. I will do this here, for example, for strain designation. Yeah, I can search here and with this asterisk, and you see it occurs here, all the strain designations, and I get a feeling, okay, what's in there and how can I query, and then you go on from that. Also important here at the top, you see all the filters coming up, and then you can delete those again and get back to a former entry. Okay, I want to go on here. Within the morphology section, we have something like gram staining. We have cell size. This is a numerical field. So this is a third type of data field. Sorry. Yeah, here you paste in a numerical value and can query this. And you have different operators here. You have the equal, lower, higher, and between. Yeah, you can choose this and thereby narrow down your list here, right? We have other fields that I want to show. This ability of spore formation, for example. We have oxygen tolerance, if this is an aerobe and anaerobe strain. And then we have metabolite utilization. I already showed you the table on the strain detail page. And this is also here probably the most interesting field because you can, yeah, place here in, right here in a metabolite name, and then decide, okay, is this utilized or not? And query this one, right? And you see from the results, okay, this looks good. But you see his sodium citrate as well, and you can then say, okay, I only want to have exactly citrate. What you also can do is you can specify the kind of utilization that is tested. But I won't do this for the beginning. You can do this later on, but yeah, this will really restrict it. Will be very restrictive here. Okay, we have enzymes that you can query here. We have culture medium that culture media that you can query here. Temperature values, like 30 degrees. Again, you can say lower, higher, between, like this. And pH is pretty much the same. Isolation and sampling I will skip for now. We have pathogenicity data, like risk biosafety level. We have sequence accession numbers that you can query here, and I will skip those. Probably interesting for you is references as well. You can search for authors, search for journals, and all this stuff. So what would you do with this list now? So you can, again, select all the strains and put them into your download selection. But you also can link this page as a result. And this is stable. And Let's show me that. And you can also download a list of BacDive IDs, which can be quite handy if you, for example, use the RESTful web service and want to retrieve more data. This can be a handful for you. Okay, these are the major things that I wanted to show you here. And with this, I want to switch to our second search, which is totally different. That's why I want to show you. This is also somehow younger than. This is our isolation source search. So we have isolation source data for about 45,000 strains here. Isolation source data usually looks like this. It could be a word, it could be a short sentence or something like that. This is mostly combined with country data and sometimes with the location here. And as I said, we have this isolation source keywords here. And like this here would be one keyword. And we divided these keywords into 3 levels, with a very first level, which is very coarse, and in the third level, which is very fine. And how this works, I will show you now. So on the top left, we have this filter functions, and they pop up here. We have 3 different filter functions, and we have this isolation source categories at first. And typically, you would go from the left to the right. So you start by selecting environmental, aquatic, and then you submit this keyword. And this is filtered by all the aquatic entries that we have in BacDive, you see here. But you can refine this. You can go on and say, okay, I don't only want to say it's aquatic, but I also want to say it is marine. And then you filter for marine. Let me delete this one because this is the same. And then you have about 2,000 strains left. You can now add other keywords as well. For example, we can add now host data. Say, okay, I want to add now algae, for example. And then I get all the data with algae and marine environment here. And this is only 55 strains here. This is a big advantage because if you query this data field, you are able to query this. I can show you in a second. You would never get that result of 55 strains. So let me delete this for now, and I will go on with the second section. So here you can query the sampling data. You can query the country, for example, the continent, the location, and so on. I won't do that for now. And you can also query taxonomic data here. And for example, you can query here for the family Streptomycetacea. I selected that one because it's a quite large family here. And now you get all the isolation source information that we have for the Streptomycetacea. And you get a long list. Okay, what can you do with the data now? You can have a look on our map here and see the distribution of the isolation sources of the Streptomycetacea, for example. We have also coordinates here that you can show. But you can also download the data, put this in a download in this download selection. You can, here on the right side, you can download the whole table as it is. That was a user request once, and we thought, okay, this is a good idea. Download the table. And then you can do something that I really like. You can open this chart for this selection that we made here. And what this chart does is it's a chronoplot. It gives you an impression of all the keywords for the selections that we just made. And what you can see here, it's a little bit small, but I will read it for you, is that it's dominated, the Streptomycetacea isolation sources are dominated by soil. Of course, it's a soil bacterium. The host where this was isolated is dominated by herbaceous plants. And on the host body side, this was mainly isolated from the root or rhizosphere. So thereby you get a quick impression of all the isolation source tags that are available here. You can also go into this and have a detailed look on the host, go back. You can also make a snapshot here. You get an SVG for whatever reason. And you can also link this. Again, this is a stable link, and you can link this and send this to the colleague or so. And why I like this feature so much is you can use this with any kind of selections that you did before, not only on taxonomy level, but you can, for example, also by country level. You choose the country and then see the distribution of this text. So this is a nice tool to get a fast impression of this selection. Okay, with this example, I will get back to my presentation. So after this live demo, we would like to have a short rally with you. So how this works is it is really short, and we have a Google Doc available. And within a few seconds, my colleague will post this Google Doc in the chat. Oh, he did this already. And let me get to the Google Doc. So the idea is it's your turn, look up the question that we did, that you post there, and try to answer it as fast as you can. I will wait for 1 or 2 minutes, and if you have a result, paste it into the Google Doc. So that's the idea. I will see if this works out. If this doesn't work out, I will show you anyway in 1 or 2 minutes the result. So I go back here and go. So again, sorry. So yeah, there you are. So this is our question. Please go ahead and try to answer this now live. Yeah, that's a correct answer. Okay, that was someone really quick. I really didn't record it who is this. But yeah, that works out. So give me a short, so I will show you now how to do this for those who haven't done it yet. So that's the result basically. So you query Firmicutes, you say it's a type strain, you query gram stain positive, the cell shape here, you say it's anaerobe, you say it's glutamate, able to utilize glutamate, and it's positive. And then with all these filters, you should end up with this answer. So that worked very good. So now I would ask Joachim to paste in the second question. So then you can go for the second point. So that's now. We are looking for a strain that was isolated from a reptile in freshwater. Obviously, the best way to do this is isolation source search. Was an answer in the chat? Yes, that looks good. There was an answer in the chat. So how is this done? So let me get back here. So we have here isolation source categories, and just go for environmental, aquatic, and now for freshwater. And in the second keyword, you go for host and for reptiles. And then you have this entry here. Okay, thank you for participating here. I like that. So in the very end, now I want to give you a few impressions what BacDive is used for, because we offer the service, and this, of course, is used, and so you get an idea what you could do with it. This was a paper 1 or 2 years ago. What they did is they analyzed the infant gut microbiome. They identified the bacteria in there, and they assigned traits from BacDive, like pH preference or metabolite preference, things like that, and tried to reassemble the microbiome here with the traits that they got from BacDive. The second example is just recently the Genome Taxonomy Database, GTDB. You might know they're actually using BacDive to identify the strains, to resolve the identity that is assigned from the sequence accession numbers to the strains. So that's somehow this problematic that I explained with the different culture collection numbers and so on. So we are matching those. Then a third example is a very nice example because it also involves Brenda database. So here, the researcher around Enquist here, they use the gross temperature data from BacDive and the enzyme catalytic optima from Brenda, and they use it for a machine learning approach to predict gross temperatures for new bacteria. So I really like this, and this is somehow a good hint what you can do if you have systematic data, comprehensive systematic data available. So in all these times where AI is so important. And of course, the last thing I want to show you or to mention here is we do this on our own as well. We make use of the data. We have this Diaspora project here. And one of the things that we do here is we use these properties that we have in BacDive together with the genome annotations, also to try to predict properties for the so far not so good described bacteria. So this is something where you really need all this data standardized, available like it is in BacDive. So with this, I want to close this. We are 45 minutes. It's quite okay. This is diasporaproject.de. Go there for more information. And of course, this is a BacDive team and the active members and also some former members. Just to highlight here, this is Joachim Sader also here. This is the main web developer here, and Julia Koblitz here. This is a newest member, and she's doing a lot of cool stuff, and you will see this in BacDive within the next months and years. So with this, I want to thank you for your attention and also that you spent all the time here with me. And if you have further questions, don't please ask them, and you can also contact me later on via email, of course. Thank you.